So what we have here is our OpenWay Riva Distributed Intelligence App Demonstration Board. So what are all of these components? Well, we have our 3 OpenWay Riva meters, but what's everything else? This is a model of the low voltage distribution system. So we have a transformer behind the board. Then we have a line that feeds several meters. And so think of this as just a small slice of the low voltage distribution on a transformer. Coming in to feed each meter, so our line comes from the transformer through this box, which I will get to in a moment. Then coming into each meter is this black box. What is that? Well, most of these applications work on detecting the small voltage changes that occur when we pull currents into a meter. Of course, a real distribution line, even in the low voltage, the service drop is quite long, and so these are very tiny lines, so we have very little resistance here. So all these black boxes are small resistors to simulate the resistance that's in that service drop. This little gray box feeding into the inside of the meter, and we have another little gray box on the outside of the meter. This will be used when we demonstrate stealing power. And this has a jumper cable that allows us to jumper across the meter. Then to the right of the meter, we have a load box. This contains 4 loads that we can switch manually, or there's a mode where there's a controller inside that will switch these loads automatically. So this is where we simulate the loads changing and the currents changing from the loads inside the home so that our applications can pick up those small variations in voltage that occur with the currents and recognize the various conditions that we're going to show you that these apps pick up. Each of these has 4 loads, and when the light is on, the load is on. As well, on each we have a voltmeter and a wattmeter, and we will be using those as part of the demonstration. Coming from our first home along this distribution line, we go into a second home through a second resistor, same purpose as we talked about before, feeding this home, and again a second load box, which is our second home. We move from there over to our third home, again through a resistor that represents the service drop, and then into this meter. The load on this meter looks a little different from the other 2, and the big difference here is this is inside a plastic box. The reason that this is inside a plastic box is because we have a Wi-Fi enabled switch in here, and you'll see in one of our use cases that the meter will be making a decision that a load needs to be switched off and switch that load off. And obviously Wi-Fi doesn't work very well through metal, that's why this is a plastic box. Stepping back over here to the left again, there's this one extra component we didn't talk about, and this is just a rheostat, and it allows us to put extra resistance in the line feeding that meter, and we will use that to show the meter automatically detecting when we have bad connections or high impedance connections in our distribution line. And all of this together will be used to demonstrate our use cases today. In addition to the components on this board, we have some software up on the screen. And this is the back office components of this distributed intelligence. And so in several of our use cases, what will happen is the device will recognize that there's a condition, and it will notify the back office immediately over the network that this condition has occurred. And when that happens, we will see that in the software you see on the screen today.